Hi everyone. Welcome to the session on difference between generative AI and discriminative AI with examples. Generative AI differs from other AI models primarily in its ability to create new content, rather than just recognizing patterns or making decisions based on existing data. Let's get started in knowing all the major differences. Here are some key distinctions between generative AI and discriminative AI. We will discuss the differences based on certain factors such as generative capability, learning approach, use cases, goal and output, training data, and examples. Let's see each one of them one by one. Generative AI, as the name suggests, is primarily focused on its ability to generate new data or content that is similar to the training data it was exposed to. This generative capability sets it apart from discriminative AI models, which primarily focus on distinguishing between different classes or categories within existing data. The generative capability of AI models enables them to be creative and generate content that goes beyond the training data. It opens up possibilities for generating new examples, extrapolating from the existing data distribution, and even creating entirely novel content. Discriminative AI, instead, works within the boundaries of the training data and excels in tasks like image classification, object detection, sentiment analysis, or speech recognition, where the goal is to identify and label existing examples accurately. In summary, while generative AI models have the unique ability to generate new data similar to the training data, discriminative AI models focus on distinguishing between different classes or categories within existing data. Let us now move to next factor, learning approach. The learning approach employed by generative AI and discriminative AI models differs in terms of the techniques and processes used to learn from the available data. Generative AI models often make use of unsupervised learning or a combination of supervised and unsupervised learning approaches. Unsupervised learning involves training the model on unlabeled data, where the model learns to identify patterns and structures within the data without explicit labeling. In unsupervised learning, the aim is to understand the underlying distribution or structure of the data. By learning from the data without specific labels or targets, generative AI models can capture the inherent patterns and generate new content based on that understanding. The choice of learning approach reflects the different focuses of generative AI and discriminative AI models. Generative AI models prioritize learning the underlying structures of the data, as well as the ability to generate new content. They are often more exploratory in nature, seeking to capture the variations and inherent patterns within the data without explicit labels. Discriminative AI models, on the other hand, emphasize learning to identify and classify specific classes or categories based on labeled examples. And now, let us move to the next distinguishing factor, use cases. Generative AI and discriminative AI models find application in different domains and have distinct use cases based on their capabilities and learning approaches. Generative AI models are commonly applied in creative tasks that involve generating new content. They excel in areas such as image generation, where they can create realistic and novel images by learning from existing samples. Generative AI can generate new images based on given input, complete images, or even generate entirely new images from scratch. Text generation is another prominent use case, where generative AI models can generate coherent and contextually relevant text, such as for dialogue systems, story generation, or language translation. Content creation, including generating music, videos, or art, is also a significant application for generative AI. Additionally, generative AI models are employed in data augmentation techniques to generate synthetic data and expand training datasets. Style transfer, which involves applying the style of one image or text to another, is another area where generative AI demonstrates its capabilities. Discriminative AI models are commonly applied in tasks that involve discrimination, classification, or prediction. In image recognition, discriminative AI models can accurately classify images into predefined categories, such as identifying objects, recognizing faces, or detecting anomalies. Speech recognition is another important area where discriminative AI models are employed, enabling the transcription of spoken words into written text. Natural language processing tasks, such as sentiment analysis, text classification, or question answering, also make use of discriminative AI models. These models learn from labeled examples and utilize the learned patterns to make accurate predictions or classifications on new, unseen data. Discriminative AI models are designed to perform specific tasks and excel at providing precise answers or identifying classes within a given set of options. It is worth noting that there can be an overlap in use cases, and some tasks may require a combination of generative and discriminative AI techniques. For example, image synthesis can involve both generative AI for generating new images and discriminative AI for evaluating their quality. Similarly, natural language processing tasks may leverage both generative and discriminative models, with generative models used for text generation and discriminative models used for text classification or sentiment analysis. In summary, generative AI models are commonly employed in creative tasks like image and text generation, content creation, data augmentation, and style transfer. Discriminative AI models, on the other hand, are used in tasks where discrimination, classification, or prediction is the primary objective, such as image recognition, speech recognition, and natural language processing applications. The choice of AI model depends on the specific task requirements and the desired outcome in terms of creativity, precision, or accuracy. With this, let's now move to another distinguishing factor: goal and output. The goals and outputs of generative AI and discriminative AI models differ based on the primary objectives and learning approaches. Generative AI models aim to create something new that wasn't present in the training data. The core goal of generative AI is creativity and the generation of novel content. These models learn from the patterns and structures within the training data to understand the underlying distribution and generate new instances of data. The output of generative AI models is often a novel creation that goes beyond the original training data. This can manifest as generated images, music compositions, text passages, or even entire stories. The generated output represents a new instance that resembles the patterns and characteristics observed in the training data. The emphasis is on exploring new possibilities and expanding the creative boundaries. In contrast, discriminative AI models focus on accurately categorizing or recognizing patterns within the existing data. The primary goal of discriminative AI is to make accurate decisions or classifications based on the input data. These models learn from labeled examples, where each example is associated with a specific label or category. The training process enables the model to identify patterns, features, or relationships that distinguish one category from another. The output of discriminative AI models is a decision or classification based on the input data's features. For example, an image recognition model may output the label or class of the object depicted in the input image. Similarly, a speech recognition model may output the transcribed text of a spoken utterance. The focus is on precise categorization and recognition of patterns within the given data. The distinction in goals and outputs reflects the different objectives of generative AI and discriminative AI models. It is important to note that generative and discriminative AI models can complement each other in various applications. For example, generative models can be used to augment the training data for discriminative models, while discriminative models can validate or assess the quality of generative outputs. The choice of AI model depends on the specific goals of the task, whether it's to generate new content or perform accurate categorization and recognition within the existing data. Next distinguishing factor to consider is the training data while comparing generative and discriminative AI models. Generative AI and discriminative AI models differ in how they utilize and learn from the training data. In the case of generative AI models, the training data plays a crucial role in learning the underlying structure and features present in the data. These models aim to capture the patterns and characteristics of the training data, allowing them to generate new content that is similar to the data they were trained on. Generative AI models employ techniques like unsupervised learning, where the focus is on understanding the distribution of the data without explicit labels or targets. By learning this distribution, generative AI models can generate outputs that resemble the patterns and characteristics observed in the training data. The training process involves exploring the variations, correlations, and dependencies within the data, enabling the model to generate new instances that align with the learned distribution. The goal is to create realistic outputs that are similar in style, content, or characteristics to the training data. On the other hand, discriminative AI models primarily learn to differentiate between different classes or categories within the training data. The training data in discriminative AI serves as examples with specific labels or targets associated with them. The model learns to identify the features or patterns that distinguish one class from another, enabling it to make accurate predictions or classifications on unseen data. Discriminative AI models often employ supervised learning techniques, where the training data consists of labeled examples. The focus is on minimizing the discrepancy between the predicted outputs and the true labels, allowing the model to accurately categorize or recognize different classes within the data. Discriminative AI models don't necessarily learn the full distribution of the entire dataset. Their objective is to learn the discriminative boundaries or decision surfaces that separate different classes of data. The training data plays a pivotal role in both generative AI and discriminative AI models, but in different ways. Generative AI models learn from the training data to understand the underlying structure and distribution, which they then use to generate novel content. Discriminative AI models learn from the training data to identify discriminative features that enable precise classification or recognition of different classes within the data. And at the end, let us discuss some examples of both models. Generative AI and discriminative AI models are implemented using various algorithms and architectures depending on the specific task at hand. Here are examples of commonly used models in each category. Generative AI. 1. Variational autoencoders, VAEs. VAEs are generative models that learn the latent distribution of the training data and can generate new instances based on that distribution. 2. Generative adversarial networks, GANs. GANs consist of two networks, a generator and a discriminator, that are trained in an adversarial setting. The generator network generates synthetic data instances from random noise as input, while the discriminator network aims to distinguish between real and generated data. 3. Recurrent neural networks, RNNs, for text generation. RNNs, specifically variants like long short-term memory, LSTM, or gated recurrent units, GRUs, are commonly used for text generation tasks. These models have the ability to capture temporal dependencies and generate coherent sequences of text. RNNs have been applied to tasks like language modeling, dialogue generation, and story generation. Discriminative AI. 1. Convolutional neural networks, CNNs, for image classification. CNNs are widely used in image recognition and classification tasks. 2. Support vector machines, SVMs, for pattern recognition. SVMs are a popular discriminative model used for pattern recognition and classification tasks. Understanding the distinctions between generative AI and discriminative AI models guides the selection of the appropriate approach for specific tasks. Generative AI models, with their ability to generate diverse content, are particularly valuable in creative fields, such as art, music, and content creation. On the other hand, discriminative AI models excel in tasks where accurate classification, recognition, or pattern detection is required, such as image recognition, speech recognition, or sentiment analysis. Matching the AI approach to the task requirements is essential for achieving the desired outcomes and leveraging the strengths of each approach. To quickly recap of what we have covered in this video is we discussed upon various factors that differentiates generative AI from discriminative AI. That is all for this session. Thank you.